So data visualization is the display of a data in a format that user can make other viewers intuitively understand or efficiently able to deduce what the data is representing. So there are different ways of visualizing data. You can either post the data in a text form, in a paragraph form, just like this one. This paragraph or this piece of text data represents the median house prices in California between 2000 and 2010. So you cannot exactly estimate where the prices are rising and where they are decreasing, and it's not really an easy way to grasp the data. What you can do is, first you can represent the data into a tabular form, where you can easily see like what was the price in the year 2006, it was this, and you can still read the values, more readable. Okay, but still, if you were to represent that data in the form of charts, it will become more insightful. You can get the information like the prices were rising up until the year 2007, and the price rise burst, the bubble was burst in the year 2008. So it can clearly tell us what was the trend of the prices. Okay, instead of when we were looking at the table, looking at the table in the data. All right, so this is a chart can also help viewers see trends, relationship, and patterns in the data. So, for example, this chart represents the price of gold between 1971 and 2019. Generally, by looking at this graph, we can say that there is a rising trend in the price of gold, but we can also see that there was a crash in the market between the year 1990 up until the year 2010, where the prices started rising. So the investor, by looking at these kind of information in chart visualization, can easily determine it's a good idea or not to invest in the gold for a long time. We can also compare two data. Like here, the yellow color represents the prices of gold, and the green color represents the prices of stock. So here, investor can easily determine that the prices of gold and stock do not move along with each other. And we can also say that in the year 2011, gold was relatively expensive compared to stock prices. So these kind of representation and visualization techniques help us analyze the data more effectively. There is another form of representation which is called the pie chart. So like this one, it's showing the per capita availability of milk in the United States in the year 2013. And if this data would be represented in a tabular form, you might not be able to easily understand or easily deduce that the plain 2% milk is widely available in the United States in comparison to the buttermilk, which is rarely available. So this kind of representation, you as an analyst or you as a scientist need to decide which graph or chart you need to go for while presenting your data. So once you have the data, you need to decide how to choose what type of chart or what type of graph. So there are a couple of factors, among which the important one is the cardinality, which describes the number of unique elements in a data set. So for example, the student IDs are unique in this classroom. Everyone has a different student ID, which shows the cardinality of this data is high. Okay, when we talk about the ages, so most of you are in between 18 to 24 years, so the cardinality here is low because almost many of you will be sharing the same group of age. So when we have the low cardinality, pie charts or the bar charts are suitable to use. So here is an example of the high cardinality. If we represent the data with a high cardinality in pie chart, it would look something like this, which is not clearly readable. The low cardinality data should be plotted on the pie charts, which is easily understandable and readable. When you have a high cardinality, high amount of data, you better use the scatter plots or histograms. So as a rule of thumb, data set containing only one variable, better use pie chart, histogram, or box plot. Data containing two or more related variables, use scatter plot. And data in which one variable is categorical, which is not numerical, then better use bar graph or pie chart. Okay. And we have already studied some visualization libraries for Python, how we can visualize data. So out of these selected libraries, external libraries, we have already talked about NumPy, Pandas, Matplotlib, and SciPy is another external library which you can use for statistical functions, Scikit for machine learning and data analysis. So if you end up doing an internship or a job as a what is called machine learning or AI or data analysis, you must be familiar with these libraries, majority of these libraries. And in order to dig deeper, you have these links in front of you. You can go through these links and learn it yourself. The idea of the lecture is to just give you an overview of how we can present the data. Okay, so this is the end of